3D printing news Unpeeled. And today, we're going to be starting with a couple of news items for you. And the first one is by something called Defiant 3D. And Defiant 3D is a British company that just launched at TCT 360. And it is a 52,000 US dollar metal 3D printer. So that is not a lot of money. And what they've done, you can pre order the system now. And what they've done essentially develop something called cold deposit and sinter technology. And what it is kind of it's analogous or close to binder jetting or the filament based binder jetting or filament based sintering technologies that we're seeing. And what it is, it's a printer aimed at the small to medium businesses. It uses like the material cost is around $70 a kilo for 316L steel, but it should be able to do a lot more materials going forward. It's a 200 by 200 millimeter build volume printer, and it just works on a regular power supply. The idea is you buy the material in canisters that are preloaded, so you don't need a lot of or more complicated kind of environment to run the system. So it can be placed in a lot of different businesses. And the idea is it's basically a vibration assisted nozzle extrusion method. And there's two materials that are extruded, and one is the build material, and the other one is a support material. And the support material has a higher melting point. And the idea is that once the part has been printed, rather than take it to a different sintering oven, the Defiant 3D printer is its own vacuum-based sinter oven. So the part stays in place, and then the printer becomes an oven, or is an oven already essentially, and then it heats it up until like the part sinters, but then the build or the support material is the melting temperature of the material will be higher, so it actually doesn't sinter yet, and then the part can be taken out. Now this means that they don't have to take it into a different printer or debinding process and then subsequently in the sintering oven. So there's less conveyancing, which is potentially really efficient. On top of that, what's also a really good thing about this is that there's less labor, but also less binder material, or it doesn't really use a binder type compound. Officially, that could also make this system quite inexpensive as well. This is quite an interesting technology. I have no idea if this is going to work. I have no idea if this is going to be a viable technology going forward, but it's nice to see people do kind of different things and kind of things at very breakthrough price points. We're already seeing like one click metal and other printers around 100K. We're talking about $50,000. That could really be in reach. Now, of course, we know with all these sintering-based technologies, it's really difficult to dial in the sinter specifications and things like that. So this may very well be more suited to a limited number of geometries or well-qualified geometries. But if the system is just cheap, and if they can use just kind of MIM-like powders for their feedstock at a kind of reasonable price, this could very well be a very viable technology for certain cases. So I think it's great that this small company is coming up with something like that's quite new. The next news item, it has to do with, well, it's a lamp, but it isn't a lamp. It's a wind turbine. So Ross Stevens and Nicole Hone have worked on the Power Pot plant. Essentially, it's a potted plant inspired wind turbine. So it's made out of PLA, and it's a wind turbine. The idea is that it's a bio-inspired type of wind turbine design that uses just regular FDM PLA material to do its work. Now, the wonderful thing is, as printers get larger, as we get more pellet-based, extrusion-based systems that are much larger using robot arms and stuff, as we get more systems that have like medium format systems and stuff like this, we're going to see a lot more kind of consumer type, industrial type products that are much larger than we're used to using these desktop printers. Because before, you could make this on a powder bed fusion system, it'd be too expensive, or in a material extrusion system, you wouldn't have the build volume. And now all of a sudden, people are finding out ways to screw things together, stick things together, or use these larger systems to make more consumer-oriented products. It's nice to see that you can still get a lot of mileage out of just using a 3D printed product like this and making it out of PLA. And I would expect a lot more inventors and designers and people to really make a lot more products that are more human-sized with 3D printing going forward. So this is why we're closely watching this space. Now, the next item has to do with Norsk Titanium. Norsk Titanium is a company that, among other things, has a wire-based DED technology. Now, wire-based DED, directed energy deposition technologies, are really cheap because we can use this as a regular kind of welding wire type of material. Usually they're near net shape. As you can see, the parts in front of you, they're kind of rough, and you would need to heat treat them, machine them down and stuff, and that could take actually much, much longer than actually to build. But compared to powder diffusion, these other things, less intricate parts, less fine parts, way rougher surface texture, but super cheaper, and we can make them much bigger. We can make parts up to meters and meters in length. So that's a real advantage. And we can see parts that parts that are in the future, not yet really viable at the moment, but we could see really large wing spars and other kind of structured aerostructure type of things, chassis components, or maybe even entire chassis of cars. Really large oil and gas components, and things like that. And then this really changes the applications where usually we need really expensive, small, weight saving, really tip of the spear type of stuff. And now, well, it could be a really large thing that needs to be in a remote area, or we just need to make it really quickly, that kind of stuff. So a lot of new business cases could be enabled by this technology. Anyway, Norris Custodial is working with Questech Innovations, which is a software kind of company, to develop nickel alloy wire, so Inconel type or Inconel similar type wire DED processes. Now, this again has an oil and gas and aviation, a lot of applications, all these nickel super alloy materials. And then by making them significantly cheaper, you could have a very, you could have a really great product here. What they're doing is for this rapid plasma deposition, which is like North Titanium's name for its own process, and the Questech software, they're trying to dial in the settings, they're trying to dial in the heat treatment, they're trying to dial in all the parameters they would need to do this. And this is essentially what the companies are going to be doing together. Now, this is very promising. There's a couple of companies that can do similar things. There's a couple of companies that have been doing stuff like this and welding type processes like this for a long time, like Siaki and Optimec and stuff. And this company's having a lot of success now with similar type processes like Meltio and stuff. So all this is pointing to a lot more innovation in the DED space, and there's a huge amount of potential there for MRO, for oil and gas, energy industry widely, and also just the military and stuff like that. And then ultimately, I think chassis components for cars, imagine like weight optimized, really inexpensive chassis and stuff like that. That could be a huge application. Anyway, this was the news for today from 3D Printing News Unpeeled. Thanks to 3dprint.com. My name is Joris Peels, and I hope you found this very, very useful. Have a great day.